Hello, I'm Dennis K. McKay. Welcome to this episode in the video series I call SurveyorThink. Previous episodes in this video series referred to the need for a national standard for surveying data. This episode hones in on the basics of my proposed design, which builds upon and reimagines existing national cadastral standards. What I am discussing has no product to buy. It is a neutral specification which any software app could be adapted to utilize. For years, there's been a national cadastral standard developed through the FGDC, led by the Bureau of Land Management, and includes efforts by many levels of government and private sector. It is known formally as the Publication Standard for the Cadastral Framework Theme of the National Spatial Data Infrastructure. Its shortened name is CAD-NSDI. The geometry involved in CAD-NSDI is parcel polygons and parcel points. The standard has no survey measurement data, as its intended audience, the general public. Originally, the publication standard was conceptualized with a complementary standard called the production standard. The production standard would house the surveyed bearings and distance of lines and the coordinates of control points. Its audience would be surveyors maintaining the CAD-NSDI. But no such standard was developed. The only national survey measurement standard developed by committee is the Multi-State Cadastral Corner Database, enabling surveyors to share GPS measurements amongst themselves and with GIS parcel mappers. My proposed surveying data standards add two surveyor-centric geodatabase standards to the publication standard, where 3 geodatabases are continuously published as infrastructure. The production standard has been completely reconceptualized to support a temporary offline editing environment that would be integral with the entire surveying process. These reimagined standards are necessary to bridge the gap between ongoing survey measurements and the need to quickly and easily update the CAD-NSDI with more accurate geometries. Here's a bird's eye view of my 4 proposed surveying standards. The first standard I call a parcel geodatabase, essentially the point and polygon aspect of the CAD-NSDI design. It differs from CAD-NSDI only in some under-the-hood variation of one of the fields to allow the CAD-NSDI to interact and synchronize with my other 3 surveying geodatabases. In a perfect world, the next version of CAD-NSDI will include this small change. The second publication geodatabase of my proposed standard houses survey measurements, and I refer to this as the Survey Measurement Geodatabase, or simply the Survey Geodatabase. The Multi-State Cadastral Control Database design mentioned earlier is adopted as the control point measurement portion, except for a few changes to clean up some things and to play nice with the other surveying geodatabases. The Survey Measurement Geodatabase goes further, though, by including tables permanently housing historic survey plat bearings and distances of lines, as well as adjusted coordinates. These adjusted coordinates result from least squares analysis, combining the weighted line measurements with the weighted control point measurements. The adjusted coordinate values and their suspected unreliabilities change over time as new and better measurements are added to the measurement tables and new adjustments are performed. Within these databases are tables of information about the official source documents, auditing information, and other details to allow validation of the database values against the source document values. So that is the parcel geodatabase and the survey measurement geodatabase descriptions. A third surveying publication geodatabase I am proposing is called the Survey to Parcel Geodatabase, containing instructions for the morphing of survey lines into parcel lines. The coordinate geometry instructions for the subdivision of PLSS sections is an obvious example. This morphing process also involves the prevention of tie lines with interfering with the parcel geometries, and the addition of imaginary offset lines, such as easement lines and setback lines that are not surveyed, but whose dimensions are defined. Definitions of circular, spiral, or median line curves help morph long chords or other straight lines used in the adjustment into curved parcel lines. Unsurveyed topographical boundaries like creek center lines, ridges, road center lines are included in this database as line sequences. In all, These survey-to-parcel geodatabases depend on adjusted survey measurement coordinates for generating the parcel boundaries. These instructions in the geodatabase need to be re-executed after each adjustment to automatically refresh the parcel geometries. The fourth and last surveying standard is an offline geodatabase called a survey analysis geodatabase, and what has become my version of the production standard for cadastral data. It consists of data extracted from the 3 published geodatabases, but only for a small patch of ground like a job area. The data is used to explore and edit the national infrastructure. The geodatabase is created by any surveyor by sketching a job area on a map. Once a job area is defined, it will be named, then downloaded as a single file for offline use by the surveyor. This file will be a geopackage file and could optionally contain any number of data types, including monument photographs and plat images for that area. Surveying software of the future, regardless of device, would read and write to the geodatabases in these geopackage files, even adding a record to the control table immediately after any GPS observation and quickly readjusting the survey network with the new coordinates. This geopackage file would be handed off through the usual stages in a survey organization until the plat is signed. The official paper plat and geodatabase job file would be submitted to the proper recording agency or agencies. The final authority, such as a county surveyor, could see in the geopackage file what the infrastructure would look like in that area once it is integrated. The procedure to update the infrastructure databases would not need effort. The striking feature of these 4 geodatabases is that they contain permanent records for the features in the infrastructure. These permanent records for every parcel, polygon, parcel point, survey monument, survey line, source document, and so on allow for a single place to keep appropriate information, as well as protecting the tight interrelationships among these various elements during maintenance sessions. An example of interrelationships is a parcel corner, such as a section corner, will have a permanent presence in the infrastructure and has a unique ID available to all users, and parcel lines are drawn to this point's current adjusted coordinate value. It is possible to have multiple monuments purporting to be that parcel corner, and each monument has its own permanent place in the infrastructure where all information about each monument is kept. This provides an open inventory of this kind of pincushion survey monument problem, instead of just sweeping it under the rug. Most common, though, is a single monument for a particular parcel corner. But in any case, the monument can have several control point measurements over time, and each measured control value will have its own record in the database, its own permanent ID, with information tied to the when and who and how. There, of course, are interrelationships between points and lines and polygons, and it is a waste of time to have to rebuild these relationships during each editing session. The offline editing environment will contain the permanent IDs of every element harvested from the infrastructure and could possibly create new IDs for new measurements and other elements created during survey, field, and office activities. When this offline survey analysis geodatabase updates the infrastructure, there's enough information to automatically change attribute values in known features and to automatically add new database records to incorporate new features. A working national spatial data infrastructure will need to be maintained constantly with the results of boundary surveys. My proposed surveying data standard is designed to accomplish solid, rapid maintenance with a minimum of extraneous effort. Thank you for watching this episode of the SurveyorThink video series.